All right, let's do a quick video on slopes of curves. So we have an equation given, y equals 3x squared minus 2x plus 4, and its corresponding graph on the right over here is parabola. And what we're saying is the slope of the function m at any point on the curve is determined by this m equals 6x minus 2. So what I'm going to refer to that as right now is what I'm going to call the slope generator. So that m equals 6x minus 2 is what we call the slope generator. Here's what I mean by that. So part A, what is the slope of the curve at 212? So I'm going to plot this point 212 on the graph. And if I were to draw a line that just barely grazes the graph and touches that point only, we would call that line a tangent line. Remember, it hits the graph one time. So what we're going to do is determine the slope of that blue line that I just now drew on our graph, where it just touches that point one time. All right, and the slope generator is going to do that for us. So we're going to say that m is equal to 6 times the x value, the x coordinate, our point, so 2 minus 2. So the slope of that tangent line is 10. Now, part B is asking, is the graph increasing or decreasing at this point? Now, we can see that it's increasing by looking at the graph, but what I'm basically asking you on this problem is interpret what the slope tells us. All right, because obviously we're not always going to have a graph in front of us. So we know the graph is increasing. Okay, so I'm going to go and write that. It's increasing. Here's why, though. It's increasing because the slope at this point is positive. Number 10 is a positive number. Therefore, our function must be increasing. So it's increasing, and if the slope is positive, the function is increasing. So part C, use the slope to determine if the curve is increasing or decreasing, x equals 0. So all we're looking for is it a positive number or a negative number? We plug 0 in. So our slope generator would tell us, so 6 times 0 minus 2 would give us a negative answer, right? A negative 2. Therefore, our function must be decreasing. Decreasing because at this point, the slope is negative. Barely fit in there. All right, so the slope is negative. All right, part D. Write the equation of the line tangent to the curve at x equals -1. All right, so to figure out the equation of a line, we need 2 pieces of information. We need a point, and we need a slope. All right, so our point, well, we know the x coordinate is -1. To determine the y coordinate, we're going to take this -1 and go back up here and box it and plug it into our original equation. So we plug -1 into that. 3 times -1, -1 squared is 1, so 3 minus 2 times -1, so plus 2, 5, plus 4. So we know it's -1 comma 9. That's our point. All right, and to determine the slope, 6 times -1 minus 2. That is to say, the slope at that point is -8. So to write the equation of our line that's tangent to the curve, you can do it in different forms, but I would just pick the point slope. It's the easiest one. It's the information, as far as in this problem it is, information given to us kind of plays into that. So y minus 9 is equal to -8, our slope, times x minus -1. So we'll just say x plus 1. And there's the equation of our line that's tangent to the curve. All right, so part E. Let's see if this orange pops up here. Algebraically, find where the slope of the tangent line is horizontal. Well, if we're talking about a slope where it's horizontal, that would imply that our slope is equal to 0. All right, so basically we're trying to figure out when is our slope 0. So we go to our slope generator. Let's plug 0 in for m. And that'd be 0 equals 6x minus 2. We would get that x is 1/3. All right. And if we're talking about where, well, we're looking at this graph, that would be a point. So we have 1/3 as our x coordinate. In order to figure out the y coordinate, take our 1/3, plug it back in up here again to our y equals 3x squared minus 2x plus 4 equation. And I believe if you do that, you should get something like 11/3. All right, so I'm going to go ahead and plot that point. 1/3, 11/3 is right here. And if you were to draw a line, this tangent to that spot, you can see that's exactly what we're talking about. The slope would be 0, and it's just barely touching that graph. All right, so the last one. Does a max or minimum occur at that point? Now, we can visually see it's a minimum, but what I really want to hear is for you to look at it in terms of not having a graph necessarily in front of us. And so here's how we do that. So determine if there's a minimum. All right, we had to look at kind of, trying to get my mouse to pop up. There we go. So does a min or a max occur there? Let's go to our number line. Right, this number line is going to be referring to our slope, so I'll put a little m. And if we look at part E up in this problem, we already know that the slope is equal to 0 when x is 1/3. Okay, so that's what we call like a critical number, right? So we can put on our slope at 1/3, that's when we know our slope is equal to 0. What we're trying to determine is what's happening to the left of 1/3. Is it a positive answer or a negative answer? What's happening to the right of 1/3? Is our slope positive or is it negative? Okay, so what we do is just plug numbers in. So like 0, plug it back into our slope generator and see if we get a positive or negative number. Well, we did that on part C up here. We've already done that. And we got -2. So we know that all our answers are going to be negative on that interval. All right, so then after 1/3, we would plug a number in that's bigger than 1/3 into our slope generator and see what kind of value it gives us. And we did that one earlier as well. I think we got our very first problem. Let me scroll up and take a look. All right, was when it was 2, which is definitely bigger than 1/3 for part A. And that's when we got 10, which is definitely a positive number. So after 1/3, our slope is positive. So if I were to draw this, some people like to do it this way. If it's negative, if the slope is negative, they draw a little arrow right here to indicate that the function is decreasing during that interval. And if it's positive, they draw an arrow to indicate that the function's increasing. Okay, some people like to actually write little abbreviations, decreasing, increasing, instead of drawing the arrows. It doesn't matter to me. It's whatever you prefer. But we can visually see, does the min or max occur there? Well, if the function goes from decreasing, right, hits that horizontal tangent, which is the 1/3 where the slope is 0, and then goes to increasing, that would create this, you can see it. It's going down and then coming up. This would be a low spot, so a minimum. So we go to change the pin here. So does a min or max occur there? We're going to say a min occurs at that spot because our slope goes from negative to positive, or you can say because the function goes from my pen's not working, sorry. Goes from decreasing to increasing. All right. And that's it. Hopefully that helps. If you guys have any questions, as always, feel free to ask. I'll help you out. Have a great day. Stay out of the trees.